Hello guys, welcome back to my channel. So we'll continue the chapter of continuity and differentiability after some long break I took. Yeah, so we have completed till I'll just revise once what all we have done. We started with continuity. We checked methods to prove if the function is continuous or not, and then differentiability and differentiation of normal functions, then inverse trigonometric functions, everything. Now we'll proceed for differentiation of logarithmic functions. Okay. Before that, I'll just want to give a quick introduction of log. So those who don't know log, just you can listen to this, or otherwise you can skip to the main part of the video. Okay, so what is log? So whenever you want to find, for example, let's say 2 square, you would say it is 4, right? Okay, so what if I ask what is 4? What like 2 power x? Then what is x? What will you say? So this is easy because 4 you can represent as 2 square, you know that, and 2 power x since the base is same, so you can tell us x equal to 2. If I ask similarly 8 equal to 2 power x, then what is x? You will tell x as 3, right? So what if the number is very huge? Like I will say like 1024. I mean, some of you might still know this. Like this will come under 2 power 5 6 is 64, 7 is 128, 8 is 256, 2 power 10, right? Yeah, so 2 power 10. So some of you might know this, but now what if I say, let's say 1000, what 2 power what is 1000? So we don't know this, right? So here we bring the concept of log. Okay, so if you represent 1000 as 2 power x, then you will find x as, I'll tell you, see, x is equal to, you bring, this is the base, this is the exponent, right? This you know. Okay, so you bring the base down here. Okay, so you will put log base 2, same base 2 of 1000. This is the value. Okay, so similarly, like how we apply arithmetic functions, addition, subtraction, everything, log is also a function. Okay, you, since you know functions, you can say, if like y equal to f of x is a function, right? So x is an input and y is an output, right? So already trigonometric functions, let's say sine x, you apply sine into this x, right? So you get some y. Similarly, you apply log for this 1000 with base 2 to get x. Now to find the value of this, you may ask, right, now what is the value? Like we'll have to report some value like this, right? 2 or 3 something. So there's something called log table, guys. Okay, if you I think in chemistry or something, you will need this like log table or something. But there also, if you prepare for JE and all, they'll give the values directly. Okay, so that you can, like, you will solve a big question and you will get the answer like this, and for this value they'll give directly, so you can substitute the answer. But the goal of this video is not that. Okay, so we'll not teach log table and all. If you want, you can search online like how to read values from log table. The point is, if I take log and is it possible, like, if I get some function with log and then I can differentiate, I can, it's also a function, right, as I told, and I can differentiate or integrate or anything. So generally, if you tell, a equal to b power x, then x is found by log uh, a to the base b. This is how you tell it. Okay, log a to the base b. Now if you want to write the inverse of this, bring b this side. Okay, so like it is like lifting x, b is lifting x, so you can remember like that. So b power x is equal to a. Okay, so this is very easy to understand, I think. So we'll now move on to the properties. Okay, like we in this chapter, sorry, in this chapter we would need only the properties. Okay, mainly the properties, and then I'll teach you how to differentiate and everything. Okay, because this finding log value and all is not important for us now. So yeah, so what are properties? Like you can see here, I've attached one image in the like in the right side, right, in right side of your screen. So how are these properties useful? I'll tell you. Okay, one second. Okay, so Let's say I take log of, I will go with first property, okay? It tells log of x into y. I'll follow the same notation maybe if you want. It tells log of m into n is equal to log of m plus log of n. This applies to any base, okay? Here they've given base b, okay? So all these three bases will be same. So this applies to all the bases, okay? So what does this mean? Like if you say log 6 you to the base anything, okay? So you can write it as log 2, um, yeah, log 2 plus log 3. Why? Because 6 can be written as 2 into 3, so it can be split like this. The proof is like very simple only, but I will just tell proof for this one and some two or three properties. Others all are very easy, you can try to prove if you want. Okay, so we'll take m equal to some b power x, okay, and n equal to some b power y. Okay, so when you multiply m into n, you get b power x times b power y, which gives m into n as b power x plus y. Now take log on both sides. You can do this, okay? Take sign on both sides. We tell that, right? So you can take log on both sides. So okay. Otherwise, I'll first teach you this one, right? So if it is like this, okay? If it is like this, you can. You remember the I said a few minutes back, right? So I told a equal to b power x. Now you can bring the b here so that your log a to the base b becomes x, right? So similarly do here also. So your log mn to the base b will be x plus y. Now similarly, if you do m equal to b power x, if you do the same thing, you will get log m to the base b equal to x. Similarly, log n to the base b equal to y. Now add both. So you will get log mn base b equal to log m to the base b plus log n to the base b. Understood? Very easy, okay? You don't need to remember the proof also, like, I mean, it's not required. So yeah, we'll see the next property also. Like this is this need not this does not require any proof. Similarly, you can prove this, okay? The second property will be if you do the same thing, log m by n. This will be log m minus log n. Okay, same thing. Like if you want to write like 12, maybe let's say 6 only, log 6 can be written as like let's say 12 by 2. So you can write log 12 minus log 2. Just telling with you for an example, okay? Just this is not a right example, but yeah. So similarly, if you see, there's one more property. This is very important, guys, okay? Log m power n, it will be, if you bring n outside, it will be n times log m. Okay, so for example, let's say log of 100 can be written as log of 10 square, right? So you can do 2 times log 10. Understood? How this comes? uh, Quite simple only. We'll take n, let's say n equal to b power x. Now this will give log. You should be able to write this, okay? With practice it will come. Okay, just bring b here, apply log, that's all you'll get. Now after this step, what are you doing? You are writing to the power n, okay? B power x times n, okay? This will be b power xn, right? Now again apply, like, do the log, okay? Log of base b, it should be m power n, it should be x into n. Now what is x? Substitute this here. It will be log m base b times n, I mean n, okay? So what have we proved here? Whatever is there in the power, you can bring that outside here and you can multiply. That's what I've told, right? 2, if you bring here, this will mean the same thing, log 100. Similarly, you can do this also. Similarly, you can do log of n power 1 by n will be 1 This is not a separate property though, but yeah, you can do this, right? Same thing, power you can bring here. Now the next property will be um, root. Yeah, okay. Yeah, I was supposed to tell this only. Like this is very easy. Like log of uh, like nth root, right? So it will be uh, yeah. Sorry, this only I told you, right? Like nth root is what? N power 1 by n. So you can bring into 1 by n this side. Same thing. Okay, I told you this. Sorry. Now next is change of base. Yeah, this is very important property. You can take any log. Let's say suppose a base b. Okay. If you want to change the base, okay, this is very important. You will see questions later. If you want to change the base to let's say x, now what we will do? You will keep a like this, and then you will do x itself, and then you apply b. Understood? So conversely, if you want to take x, like these are two bases, right? You can switch bases like this. Understood? A B A B. Okay. And this is one more important property. Again, proof is not required. It's very easy. You can try to prove also. Yeah. So next one is log of one. Okay. Log of one is zero base. Why? Can you guess why? There is no proof at all. This is direct rule. A par x is b. What you do to find x? You apply log base a equal to x, right? So do the same thing. Log of 1 is x. Something here, okay? It can be anything, question mark. Any base is 0 only, okay? What raised to the power x will give you 1? Understood? Anything to the power, like what is 1? X will be 0, right? The base can be anything. A power 0 is 1, b power 0, anything to the power 0 is 1. Hence log 1 is 0. Okay. So, and log of same number is again 1. This is also same thing. Like if you want to find log of a to the base a, what is it? Simple, you can answer. Bring a here. A power x is equal to a. Under what condition of x it will be true? X will be 1, right? So log value with the same base will give you 1. Okay. This is also same. These rules are not required. I mean, if you want, you can just see one rule I will tell you. This is one important rule you will see everywhere in the calculus. Log, let's say some x is there, here x, and again here you have base a. Okay, so you are writing x power log a to the base x. This will be a directly. Uh, I will suggest you to try this proof. Okay, and not very complicated at all. You can just start by taking again some y equal to a power x and then proceed. Okay, it will be very easy only. Which brings me to the next point. These type of properties generally apply to base e. E, you remember, right? E is what Euler's constant 2.73 e. Okay, so e is very important. Okay, you know, e power x is a function, and then you will have log x, right? These both are like mirror images in the graph. Your e power x, your log x will look something like this. Okay, your graph, and your e power x will look something like this, like this, something like this. Okay, like this is not very good drawing, but yeah, you can understand the mirror image property like this. Okay. So these both are inverse relation, having inverse relationship. Okay, so your e is Euler's constant. So generally, when you write log in mathematics, it means log base 10 only. But in calculus, whenever you see log of some x, right, you can take that as e to the base e. Okay, this can also be written as ln of x. Remember this, very important. Okay. So that's all. Not very log is not very complicated at all. You can just remember these properties I have shown here. Okay. Now let's proceed for the calculus part. It's already getting late. So yeah, uh, your first question from exercise mm, 5.4. Okay, you can take exercise 5.4, and I will probably put it in the whiteboard. Uh, Differentiation is very easy. Okay? Integration is very hard. But anyways, I will teach you some questions here. Okay. This is your exercise 5.4. Okay. In fact, these questions does not require log. I think let's see. Okay. Exercise 5.4. I'll just solve some questions. Your first question will be e power x by sin x. Yeah, I forgot to mention one thing. Your differentiation of e power x will be e power x only. Very, very important, right? Okay, very, very important. Similarly, if you see your differentiation of log x, okay, log x as in I told you, right? What is log in calculus? I mentioned you log is nothing but log to the base e, log e of base x. This will be 1 by x. Okay, just this is very important. Remember, okay. So your e power x by sin x, you can apply u by v here, right? What is differentiation of u by v? v du minus u dv by v square. I've taught you all this, okay? So you can keep sin x. What is differentiation of e power x? E power x. Sorry, okay, yeah. And then what is u again? E power x. And then dv is x. Uh, your dv will be differentiation of sin x is what cos x, right? And then is divided by marker stuff. Okay. V square is sin square x. So this will be nothing but e power x if you take common, it will be sin x minus cos x by sin square. Very easy one. Okay? Next one is I will consider e power sin inverse of x is easy. If you remember the trigonometric function, which I told you, trigonometric differentiation, which I taught in the previous exercise, this is very easy. I'll just give you clue, you can try, okay? What is e power sin inverse of x, right? So this is nothing but you can apply chain rule. Okay, first you have to differentiate e power this one. This function will differentiate. What is e power anything? E power anything is the same thing. So this will be e power sin inverse of x only, and then you have to differentiation of sin inverse of x. You apply this. Okay, that's all. Very easy. This is chain rule. This also I have taught you. Similarly, e power x cube is also same thing. You have to differentiate e power x cube first. So e power x cube will come first, and then x cube you have to differentiate, which is 3x square. Simple, okay? And this one you have to do. Uh, Maybe this one I'll tell. Question 5 is nothing but log of cos of e power x. This is nothing but 1 by cos of e power x. Why? Because log of x is 1 by x. See here the base is not mentioned, right? You can keep it as e only. So if they specifically mention a log to the base something else, you have to think and differentiate. I will come to that in the next part. But for now, it is base e only. So log x is differentiated 1 by x. So 1 by cos e power x into cos e power x is differentiate. What is cos of x differentiation? Minus sin x. So it will be minus sin of e power x. And then e power x we will differentiate again. So this will be e power x again. Understood? So this will be minus tan e power x into e power x. Simple guys. Okay. Chain rule you should not forget. Okay. Uh, this one is very easy. This one is e power x is again e power x. E power x square will be similarly e power x square into 2x. Like that you have to do till e power x power 5. This is very easy. Yeah, question 7 is interesting a little bit. Uh, root of e power root x. Okay, what does this mean? You are taking two root. Okay, this is nothing but e power root x power 1 by 2, right? If you want, you can take log and do, but I don't recommend in this. Like if they specifically mention, if it is making your job easier, then you can do. Okay, otherwise, no need. 1 by 2 e power root x. 1 by 2 minus 1 is minus 3 by 2. Right? This is differentiation of this one. And inside will differentiate again. This inside part, e power root x. E power root x differentiation is e power root x only. And then root x will differentiate again. Okay? Just listen carefully. This function I wrote like this, power 1 by 2. So this differentiation of this function total is 1 by 2 into this one. And then e power root x will differentiate. E power anything differentiation is what? Same thing. And then root x will differentiate again. Okay. This will be 1 by 2 x power minus, um, sorry, this will be minus 1 by 2, right? This is not, yeah, 1 by 2 minus 1 is minus 1 by 2. Similarly, here also minus 1 by 2. You can simplify this later, okay, if you want. Yeah, this will be, yeah, you can do this, okay. Otherwise, what I'll just tell you the log method also. If you want, you can keep y as uh, e power root x of 1 by 2. So you can take log here. Ln of y is equal to 1 by 2. Why 1 by 2 I'm coming outside? Because I told you, know, power if it is there, it can come outside. Ln of e power root x. Now you have to differentiate both sides here, okay. Again, this is a little complicated only. You can follow this method itself. Okay, this is very easy. If any doubts, ask me. Okay, and then this one is done. Log of log x. This is very easy, guys. What is log of the x differentiation? 1 by x. So again, it will be log 1 by log x because inside it is x. Treat this as x. So log x differentiation is 1 by x. So it will be 1 by log x into again inside also you have log x. So this will be 1 by x. That's all. Simple, very simple. Chain rule is very key factor here. Okay. Cos x by log x. Apply u by v, you will get the answer. Okay. 10th one is cos of, this one is also chain rule only. Directly take minus sine of this function, whatever is inside, into log x differentiation is 1 by x plus e power x differentiation is e power x only. Understood? Very, very simple. So I'll just give a little recap. Okay, just started with log. What is log and everything? Properties are here. You can use these properties. This is addition property. I mean, this is multiplication property. This is division property. This one. Sorry, this one. Okay, and then there is the power property. N can come outside, and then change of base rule. This is called change of base rule. Okay, I'll tell you where this will be helpful in the next video. And then log 1 is 0, log base to the same base is 1, and then here this is important to take a base raised to the some log function the same base, this should be same, then it will get cancelled out, you will get a only. Okay, and then I told about e power x and log x. Log x to the base e is called log x. And then these examples are very actual log. If you apply and solve the question, those questions will come in the next lecture. I think I'll just take it out. But if you have still any doubt left, you can ask me in the comment. Okay. I think this is easy to understand. Okay, guys. See you in the next video. Bye.